Okay, everybody, day 2 notes, equilateral and isosceles triangles. We can classify triangles by their angles. You've probably heard a lot of these vocab words before. Acute triangles are triangles where all 3 of the angles are less than 90 degrees. Here's a picture of one. An obtuse triangle is a triangle where one of the angles is bigger than 90 degrees. So here's a great example of one. A right triangle is a triangle with one right angle, which is a 90-degree angle, and then the other 2 angles are less than 90 degrees. And a triangle with 3 congruent or equal-sized angles is called an equiangular triangle. And each angle in an equiangular triangle is 60 degrees. We get that by doing 180 divided equally by 3. So 180 divided by 3 is 60. Other ways we can classify triangles is by their sides. You've probably heard these words before. A scalene triangle is a triangle where none of the sides are equal. They're all different sizes. An isosceles triangle is a triangle where 2 of the sides are equal, and you've got these little congruence markings to show that. And then an equilateral triangle is a triangle where all 3 of the sides are equal. And again, we've got the little markings to show it. So, today we're going to investigate isosceles and equilateral triangles in a little bit more depth, and after we get some of the vocab and theories down, then when you come into class we'll practice problems with these. So important things to know are that if you've got an isosceles triangle, if 2 sides of the isosceles triangle are congruent, then the angles that are across from those sides are congruent. So over here in the picture, when I see, oh, these 2 little markings, the side AB and the side AC are both the same, that means these angles, which we call the base angles, are congruent. The 2 sides that are congruent we call the legs, and then the 2 angles down here are base angles. It works the other way too. If you look at a picture and you see the 2 base angles marked the same, that means that the sides across from them have to be the same as well. So a couple example problems. I'm going to try 1, 2, and 3 with you and then leave number 4 for you. When I see these markings, I know, oh hey, if these 2 sides are the same, then the angles across from those sides are the same. So if that one's 72, then that one's 72. Done. So again, the math isn't really that hard. It's just knowing, oh, those 2 markings mean isosceles triangles. Here we've got a little bit trickier. I see the little markings and I know, ooh, an isosceles triangle. If this is 73, then this guy over here is 73, and then it's back to what we learned on day 1, where all in total, the angles of the triangle are 180. If I take away 73 and then take away another 73, that's going to leave me with 34 left over. So x equals 34. Next one, I notice, ooh, these angles are the same. When I see some angles the same, that means that the sides across from those angles are the same. So x plus 3 is equal to 11, so x must be 8. And I'm done. You try number 4. You should get 6 as your answer. Alrighty, now let's look at equilateral triangles. You'll notice that a triangle is equilateral, so all sides the same, if and only if it is equiangular, meaning all the angles are the same. And we've got a picture of that here. So if all the sides are the same, then all the angles are the same, and vice versa. And like we said before, each of the angles is 60 degrees. We're going to do 2 practice problems down here together, and then I'll leave you to do number 2 and number 4. So first of all, when I read the directions on number 1, it says find the value of x. The measure of angle CAB is 12x minus 24. CAB is talking about this angle. The letter in the middle is the vertex. I know that if this is an equiangular or equilateral triangle, then all the angles are 60 degrees. So I'm going to just set this, 12x minus 24 equal to 60. So I'll add 24 to both sides. So 12x equals 84 and x equals 7. On number 3, first of all, I look and I see these markings on all the angles, so I recognize, ooh, this is an angular triangle, meaning if all the angles are the same, then all the sides are the same too. So if this guy over here is 3x minus 21, and this guy over here is 18, then those two had better be equal to the same thing. Notice the angles are all equal to 60, but the sides are not. Sides don't have to equal 60, they just have to equal the same thing. So 3x minus 21 equals 18. I'll add 21 to both sides and get 39. Divide everything by 3 and get that x must be 13. So you try number 2 and number 4, and I'll see you in class.